Okay, good morning. First of all, I'm not Lieutenant Commander Kruger. My name's Alan Arnett. I've got several years of government program management, software acquisition experience. Commander Kruger couldn't be here today, so I'm going to give this presentation on his behalf. So I guess we'll get into it in the briefing, but our presentation here is probably a little bit different than the other presentations you've had today. I mean, this is as it's titled. We're here from the government for some help in some acquisition work that we have coming up. So we'll see that, get into that. So let's go on and I'll get to the agenda slide. Okay. Okay, there we go. So we'll just as an intro, we'll have a little bit of a video, and then I'll do some background, a little bit of a program overview, some technology discussion, closing comments, and then we've got a performance assessment demo that's going to be part of our acquisition. Is that better? Yeah, okay. Thanks. Okay. Is this, sorry about that.
Let's go to it. So you want to show the video?
Yeah, let's do the video.
Okay, now let's see. I wonder if the sound is hooked up on the video too. That's the other thing we do. I'm not sure that the sound's going to be hooked up. So. Now let's see where the sound. Is there a technician around? Hey, where's the sound? What do we do to connect the sound to it? I guess we're the only ones with sound.
For those of you that aren't familiar with the NRO, this will give like a little bit of an intro and talk about some of the mission and some of the things that we do. So it's available on YouTube, on the internet. So we wanted to make it available here during the presentation, just as background. That's good.
Let's try to get the sound out of it though.
There's really no voiceover. It's just music with the words that you see there. So that's fine. Just let it go.
Oh, it shows system volume. It's just not transmitting out. The speakers aren't working.
That's it.
Okay. All right.
So this just goes through the list of customers, primary customers we have, and some of the missions that we try to serve from the NRO, and list of different organizations. And then while we're here today, I mean, part of it is technology. Part of the equation for us is really getting the best access to the best technology we can get. And then in terms of innovation, again, today at this conference, the in-memory computing is as you're well aware, innovation and the latest. All right. Thanks. Okay, so as I go through the presentation, I mean, we'll try to take questions as we go. Otherwise, we're here for the rest of the conference, and we'd be happy to talk with people afterwards. Upon conclusion of the briefing, for unanswered questions, we have a site on the internet. You can see it on the next slide, the Unclassified Acquisition Resource Center, where you can post questions and interact with us through there and get answers. So, okay. So here's, just for background, here's what's required to get into the Acquisition Resource Center, and here's what information, and here's how you connect to it. So you would need to fill out that information in order to get an access account, and you'd have to have a SAMS registration and a DUNS number. Okay, just for a little bit more perspective, here's the organizational structure, all the functional elements in the NRO. And then I'm in the Ground Enterprise Directorate, where we do mission data processing. So a little bit about why we're here today and what we hope to achieve by doing this presentation. So we wanted to inform potential offerers about our upcoming acquisition, and we've titled that, for lack of a better word, BONFIRE. And then again, the government would leverage commercial expertise and investments for best value, and we want to provide to potential offerers this information, the pre-solicitation BONFIRE related information, an opportunity to ask questions and provide comments. We want to foster an environment for networking and teaming arrangements so that we can get the best resources available to get the job done. And we want to establish and keep open a line of communication between industry and the government. So just a little bit more about networking and teaming. So we recently put out a request for information to provide industry with explanations of the government's mission objectives. Why did we do that? And we put that on the ARC that I referenced earlier. And I think you can still go recall that, though the period for comments is closed. We wanted to learn who's interested in this work. We wanted to collect names and contacts of those companies for use in the acquisition. I want to post the contact information of other interested companies so that, team working could take place. And then facilitate the exchanges of names and contacts between potential bidders and the emerging purveyors of cutting-edge technologies, such as the folks at this conference. And again, here to see what the latest technologies are that could help us achieve our goals. And then last but not least, there would be discussion, get input on what the contracting mechanisms might make the most sense, or what would be the preferences or thoughts from industry, be it firm fixed price or cost plus award fee or incentive fee type structures. So let me go into just a little bit of program overview. I'll do a little bit of the program over here, get a little bit technical, and then I'll have my colleague Tom Barty come up and talk about a demo and some of a tool we're contemplating using to build confidence in any submissions we get. So this is a conceptual diagram of our processing framework. We've got BONFIRE area constitutes the area in green. As you can see, it encapsulates some other services or features, service offerings from essentially lower layers or other providers. At the top level, and the mission apps and services, that's where all the domain knowledge is. So what we want to do is isolate the domain knowledge and needs from the generic IT needs and service offerings. So we want to make sure that, for us, that would build a much more agile and responsive architecture. That's one aspect. So this just goes into the fact that we use commercial cloud services out of the iSight initiative, the IC initiative for cloud computing and a better IT structure. So we would expect all the services and applications to be hosted on C2S, a private cloud which features a subset of services found in commercial AWS. We would expect all the development, testing, and operations to be performed within the appropriate partitions of C2S, and the interop partitions its access between development, test, and operations environments. Each environment demands an increasing level of security and assurance, safeguards, and compliance. Within C2S, costs for hardware provisioning, integrated development environments, services, and software licenses are borne by the government. So all the services and apps would be expected to run in the government's private controlled access cloud. As depicted here, C2S rides on AWS. In concept, we could work across a hybrid cloud structure depending upon how the BONFIRE framework was deployed. So the BONFIRE framework, again, is the touch point. All the applications and services go through framework services in order to exchange data with each other, to get enterprise services, to get infrastructure services. The framework is a standard. Each framework service satisfies an SLA, and it hides the implementation behind an API. The framework is a performance enabler. It's high capacity, low latency, robust availability, resilient, and consistent. So this is the canonical listing of the SLAs in the framework. You could have more listings than this if you broke them down into finer categories, or you could have fewer if you made the terms bigger and conflated different aspects of each SLA. But this is one representation. So when we get to the demo here at the end, we'll be talking about exploring the data sharing service offering. Okay, and then the bumper sticker at the bottom, the framework is composed of multiple services. Adaptations or creations of additional services would be considered. So one of the things, if you look back at that other drawing we had earlier with the colors, a construct like this puts the government in making trade-offs between building specialized services or leveraging the framework. So this would allow us to be in the middle of that conversation and be part of those trades that would be made in the architecture. And again, here's some more detail. This is just a snapshot of draft SLAs. We want our framework providers to fill in the TBSs, or to-be-supplied numbers. And here's a little bit deeper dive in the data sharing service and what it would look like. Some TBDs here, but this would be the kind of information that we would try to have in an SLA or part of the SLA. We want technology, and obviously coming here to this conference, we want our technology providers to tell us how big and how fast, what's capable. And again, be part of that conversation between the mission apps and services providers and then the framework IT provider. So we're here today. We will have, we've got this tentative schedule for our acquisition. In November, we expect to have a couple of different industry days, which would be one here on the West Coast and then one on the East Coast. We are targeted to go to the Ames Research Center, and I'll show that on the next slide for the West Coast. And then we'd release a draft RFP in December, hold a bidders conference later in December, release a final request for proposal in February of 2018, receive proposals in 2018, and contract award anticipated in November of 2018. Okay. So in this process, when we release a draft RFP, feedback's requested, and it's your chance to have a conversation with us about the acquisition. Are there areas of concerns with the draft SLA that may inhibit your ability to compete in a potential source selection? Please identify the problem and recommend a solution. Is there information that the SLA should include enabling the possible submission of a better proposal if an RFP were released? Do you have additional suggestions for the government regarding the acquisition approach, contract type, or incentive structure? And then let's see, I've got contact information here for Lieutenant Commander Kruger. And then just some reminders here. Registration, roster, and presentation will be posted next to the BONFIRE ARC website, and that's the Acquisition Resource Center website. And you can submit conference questions, comments, responses via the ARC. That submission window closes 6 November, and I believe that's East Coast noon. So here's the industry days that I talked about earlier. Chantilly, Virginia, 9 November, and then NASA Ames on the 14th of November. Again, we'll be available for questions after the briefing. I've got several of my colleagues here with me. In addition to Tom Barty from MITRE, I've got Gary Frick from MITRE, Joe Scalione for acquisition expertise, and Eric Nelson from Aerospace for framework expertise. Okay, you want to talk about the test drive? Oh, yeah, it works. Just be careful when you play it.
Okay, good. Okay, good morning. So what we're going to do now is go into a little bit of a deeper dive on the data service test drive. There's really two things we're going to cover. We're going to talk about the data sharing service test driver, but maybe more importantly, we're going to give you a little bit of introduction to what the data sharing service is supposed to do. And I think when you see that, that'll look familiar. Okay. Yeah, when you see that, I think you'll maybe from some of the other presentations you'll see some commonality with that. So let's go to next slide. So is this one? Okay, can we hear? Does that work? Okay. So this slide gives you an overview of what the data sharing service actually does here. And so if you saw in the video, you might have seen that there were a number of we're talking about the National Reconnaissance Organization here. So the idea is collecting data. So what's really happening here is think about raw data coming into the system that looks like this, and we want to make sense of that data and turn it into something more that looks like that. So think in terms of left to right. So the model here basically has two key components, and the idea is to do sequential data analysis with algorithms that actually take raw data input and turn that into something that makes sense that can be used by a user that says this event happened or this activity. And we can't go into the details of what the algorithms are because that's in the classified arena, but we'll give you an overview of of how this processing works. So there's two key components here. There's the high-speed data storage, and there's the delivery and subscription processing. And the way that this system works is the following. What comes in on the left here is essentially the raw data. So that gets stored in our system as what we call a data content block. And then associated with that is a metadata block, which essentially describes what's in that content at a high level. So the algorithms down here essentially are subscribers. And what they do is they listen for certain types of data that are relevant to the job that those algorithms are supposed to do. When they get that data, they go in and they receive the metadata, they go back and they read the data content block, and then they produce a new data content block and metadata associated with that, and they upload it, and the chain continues along the way until we get to something that makes sense here at the end. So what we're talking about in terms of the model is essentially something where we have a plug-and-play type environment where we can plug multiple processing algorithms into the system. So we're talking about one-to-n algorithms, and there's essentially implied one-to-n processing threads that can come out of this. So the picture of what's shown here, and you see in the bumper sticker, the model supports a dynamic addition of algorithms and subscriptions here. So this is essentially what the government wants to buy in terms of the data sharing service. They want to buy something that has high-speed memory that can store these data content blocks and metadata and retrieve them quickly, and then they want to buy something that follows this publish-subscribe type mechanism where algorithms can subscribe information and receive information and pass that through the system. So hopefully that looks a little bit like some of the things that we've been talking about in the prior presentations. And to you folks as industry, we hope that you'll look at that and say, gee, we do something similar to that, or we can meet that model, or we can do something high speed that meets that. And if you believe that's the case, then you should attend the next events which Alan looked at, and look at who you would partner with in industry to accomplish this, and then participate in the process and move forward with putting together a proposal for it. Okay, so that's the core model, and hopefully that makes sense and is clear to those of you who've probably seen this kind of thing before. Question?
So the velocity of this one, so at what rate the data blocks are coming in, and what's the size?
So we're going to talk about that. That's coming. That's coming. And the answer to that is that that's the amount of data is going to be increasing significantly over time. What we really want to do, if you think about this, as we'll explain, there's three key functions that have to happen quickly here. There's the uploading of the data, there's the routing of the metadata to the subscribers, and then there's the retrieval. So those three things are the things where we want to have high performance. We want to minimize the latency time for those. So we're talking about high throughput, low latency systems to be able to handle ever increasing amounts of data. And we'll talk a little bit about what some of the base cases are, but we're going to multiply those base cases. Okay? Okay, so now let's talk a little bit about the test driver. So when the government does this acquisition, what they intend to do is they intend to take the solutions provided from industry, and then they want to say, and they want to be able to say, okay, here's the solution we got. How well does this solution work? And that's what the test driver does. The test driver essentially generates data content and metadata in a controlled quantity and measures the timing of results. It's essentially a form of a benchmark test. So if you remember in the previous slide, we had algorithms down at the bottom part. So when we do the test, what we do is we take this piece of software that we sometimes call the test harness, and we connect it to the DSS. We automatically generate data that's in controlled amounts and controlled sizes of blocks, and we receive the data through the receivers. And every time we go through events, we essentially timestamp those. We save those timestamps, and we do computations at the end, so we know what our throughput is and what our latency is. And for those three categories, the uploads, downloads, and the time to move the data through the system, we essentially have a collection of that data, and we can get a feel for how well one system works relative to another. So the plan here is to actually give this software to industry, give the test driver to industry, and in addition to that test driver, to be able to get it up and running, we're going to give them what amounts to a sample data sharing service, which is not going to be the objective one. It's essentially based on MongoDB and Apache Kafka. So we've written code that essentially incorporates the functions that we talked about here. But we're looking for industry to provide us with a higher performance, better scaling solution. So the idea is you get it running with the prototype that's given to you, and then you disconnect that, and then you connect your own system to it. Okay, so you'll see some of this when we go through the demo, but this is a snapshot of what the test results for this look like, and this is still work in progress, so we're probably going to be refining that. So the big questions to be answered here are, how long does it take in a given test? And in this example, we're talking about a 30-second test with 15,000 items being sent through the system. We've got our average time for the total operation for when the data was loaded, when the message about the metadata was sent from the generator to the receiver, and what the receiver time is to download. And those are broken into three separate categories here. And these are all in seconds, so you can kind of read what the times are associated with these, and you'll see that the bulk of the time here is in Apache Kafka to send things from sender to receiver, the latencies for the data loads are fairly low using MongoDB. And this is with essentially 1/100 of a megabyte of data, so we're talking about small data contents here, and this obviously becomes quite slower when we load in the bigger, the 10 megabyte examples and those kind of things, which we expect to get a lot of. But we're expecting you as industry to provide the correct answer for us on that. Okay, so for the folks that want to be authors on this, the government wants them to take the test driver software that we supply and connect it to their DSS. And this is kind of an overview of what the processes are to do that. And it's fairly straightforward. The first thing is we give you the test driver with the sample DSS. You put it on your set of virtual machines. You run it and verify that it works. Then the next thing you do is you connect to our API and you essentially do a bridge between your API for the DSS and the API calls that we make. And you see some of those examples here. For those of you who are Python programmers, this might look quite familiar. Then you run the test and you submit the results back to the government. Then the government can look at that and say, okay, well, this system was able to work at a certain multiple and it was able to send everything through with a minimum, with an average value of 10 milliseconds or something like that. We'll see how well they ultimately do. The bottom line here is there's 3 steps. Install the test driver, connect our software to your DSS interface, which we expect you to provide, and then run the test and submit the results back to the government. Okay, and this will be a little bit more apparent when we get into the demo, if you'd asked about some of the volumes. This is a very simple configuration here of the data rates that are going through the system and the data content sizes. So we've got 10 megabytes, 1 megabyte, a tenth and 1/100 of a megabyte here. So these are some values that we think are representative of the current systems, and those are subject to change in the future. So this software automatically starts up a certain number of generator processes and a certain number of receiver processes, which are defined by the test. So you see here we've got 4, we've essentially got 20 generator processes here, and let's see, we have 24 receiver processes in this example, and per second we have 936 metadata items. But what we want to do here is we want to take this configuration and we want to turn up the dial and multiply it. So we want to multiply not only the data rates but the number of processes here. And it turns out if you do that, these numbers become quite large quite quickly, because there's going to be a multiplier effect between having multiple generators and receivers and then increasing the data rates at the same time. So we'll likely provide a spreadsheet that shows what those numbers actually are. But the hope here is that you all as industry will be able to say we were able to run this at 10, 20, 30, 50 times and be able to maintain a low level of latency and see how far you can get until you actually run into a problem. So to actually run this test, of course, you will need machines that will be able to run these generators and receivers in parallel. And you'll see the software actually starts all that automatically for you. Okay. So the purpose of this is we use the term confidence for this test for this. So it isn't solely a matter of vendor A solution operated at 1 millisecond better than vendor B solution. It's more about looking at those metrics and looking at what's being proposed from the standpoint of what's the functionality being provided by the subscription mechanism. What are estimates of scalability? How well do we think this will work under different circumstances? So there's a proposal piece. And this is part of the proposal piece, but it's not all of the proposal piece, and it's not the final quote scoring mechanism that goes with this.
And this is only one service out of SLI.
Yes. So let's go ahead and let's do a quick run, and I'll show you what this looks like real quick. So I'm connected here to my servers. These are back in McLean, Virginia here, and what is going to be provided to industry as the software is essentially, as I said, the data sharing service is going to be provided, the test driver is going to be provided, and along with that there's some infrastructure which includes a web interface. We use Django to do the web interfacing here, and as I said, MongoDB and Kafka are under the hood here. So here's just an example just to show you what this looks like. So I'm going to start a test configuration, and we'll talk a little bit about what a test configuration. In fact, I'll just show you what a test configuration looks like. So a test configuration is essentially defined by a JSON file that looks a little bit like this. Can you guys see that? Oh, it kind of. Okay. Wow, it's kind of flaked out on me there. Okay, let me see if I can minimize that and bring it back up again. I think somehow it got messed up with the, well, let's run the test for now. Let's try maximizing that again. Oh, something's messed up with the interface. Let me see if we can get rid of that real quick. Oh, magnifier, I wonder where that came from. Okay, we don't want to do that. Oh boy, let's see if we can get this to come back. Bear with me for a sec, folks. We got something going wrong here. Let's see if we can get rid of this. Okay, there we go. Okay, so this is just a JSON file that defines what's going on in the test here. And basically what this does is it defines the parameters that are associated with the test, how long the test goes on for, when we do the writes and the saving of the data. We have the connection parameters to our data sharing service. We have various setup parameters that are associated with this. And then there are blocks down here that define the machines, the virtual machines that the generators and the receivers actually run on. And then we have the definition of the processes, how many messages per second they generate, what's the size of the data that goes with this. And this is the base one, but as we said on that dial, we're going to multiply that. So this base configuration is going to be multiplied by several times over, and we're going to have an incremental test that has varying messaging and data rates and so forth. So what that actually will look like when we run it is something like this. So let's go ahead to the 5 virtual machine example, and we'll submit that. Okay, so the first thing that's going to happen is we're going to go into Apache Kafka, and we're going to go ahead and start up all our topics and all the administrative stuff that has to do with getting the generators and receivers to be able to connect with each other and communicate. So we'll wait for a second for that process to happen, and then we'll see the generators and receivers come up. Okay, here come our topics, here come our subscriptions, and here come our processes. Okay. So basically what happened is I think we've got 22 generator processes and 24 receiver processes running here. We've got this thing called the distributor in the middle, and the distributor is the process that essentially receives the metadata that comes in and says this metadata is supposed to go to this receiver. So we have a publish subscribe mechanism in here, and that middle part that we call the distributor is the one that manages that. So when we go back and we schedule a test, it looks like this. We'll schedule a timing test. We'll say submit. Okay, and if you see up in the up here, you see we're scheduled to do a test, and we're going to let that clock out when we get to 15:34:34 there. Then the test is going to begin, and the message generators are going to start generating the data. You'll see them being distributed, and the receivers are going to receive them, and we're going to timestamp everything that happens as we go through the system here. 32, 33, now. Okay, so we're generating the messages and we're flowing them through the system. So as we said, the data content blocks are being uploaded, the metadata is being fed into the system to be distributed to the receivers are downloading the data content, and during the process of doing all that, we're putting in timestamping and recording the entire timing in the process here. So we'll let that test run out to completion. So you'll see that ends at 15:35:34 here. And the message rates, it's not immediately apparent, but we're actually varying the rate of message flow through the system here. And we're varying the number of generators and receivers that are generating data, and we're varying the amount of data that's being received and the number of receivers that are active and not active at any given time. And the test is broken up into sections where essentially in this model we have 12 seconds per test, but I imagine we'll have much longer tests that we'll want industry to run, since this will be part of a production system. Go ahead.
So you talked about VMs and you talked about timestamps. Are you just relying on NTP to coordinate?
Yes, that's right. So these have to be synced. These machines have to be synced by MTP. That is correct. That is correct, and we do a timestamping between the process. Okay, so now we're waiting for the final save here. So when we hit that time, the receivers are told save the final data from that. And then if we go back in and we take a look, and let's view our timing test results. We'll do our summary here. And we'll get a result file that comes from that. And this, what I'm going to show you here is essentially a summary, but we're going to get much more detailed statistics as we go through this. We're essentially going to break the test results down into sections, and we're going to say, here's the result for section A, here's the result for section B. So as we increase the flow of messages that go through the system, we're going to see how well the system did for that portion of the test and take the measurements from that. Yeah?
So are you looking at technology to do stuff, or are you looking at an integrator to implement an interface and use some technology to provide the component?
We're looking for the technology. We're looking for somebody to come along and say, here's the infrastructure that we recommend for storing the data in memory. Here's what we recommend for doing the publish-subscribe mechanism, or for being able to read the subscriptions and distributing them. So we're looking for.
Well,
you want to chime in on that?
I
That's
think your
fine.
point's well taken. We're looking for, you could almost express it as a cloud broker model to handle the data, the domain agnostic framework layer, but present all of those service all of those SLAs we talked
The
about.
distinction I'm making is there's people here with vertical technology. What I'm saying is you've got system interfaces, you want people to implement your interface to use vertical technology. So it's really a consulting gig to implement the interface to do something with a subtype system. Is that correct?
It's a larger job than providing just a point service. Right? Yeah, that's true.
Yeah, so I think we are looking for, and probably it might very well be a team arrangement where one member of the team is the provider of the technology, and the other team might be the integrator, or they might be the folks that handle the publish-subscribe mechanism and so forth. So this is just here, as we said. Here's sort of a summary of the statistics. So this tells us how many metadata items went through the system, what's the total processing time of the test, and then we go and we get our numbers about how long it took to load the data, how long it took to route the data through the system, and how long it took to read the system. So we have two modes of saving here. We actually can store every record that goes through the system here and be able to do a post-test analysis. That actually takes some processing time, though, and can interfere with the test itself. So we also have the ability to just do a summary at the end where we just collect the data at the end, and we have the receivers doing the computations as we go. But we're hoping that we're going to get solutions here from industry that are going to be lightning fast, and are going to be able to process this and handle very high loads here, and be able to handle a process coming and going, and so forth. So this is kind of a summary of what's in the test driver, and I'll show you.
Where does it give the rate? That means how many blocks per second went through the system?
So the number of blocks that went through the system.
I couldn't see it.
It's this one. It's this one right here. It's this one right here. He asked how many data items essentially went through the system. So we've got 25,296 metadata items that actually flowed through the systems and were received by the receivers. That's the So they're at So the number of blocks actually isn't shown in this summary here, but the mean data content load time is based on that average of the number of blocks that went through the system. But we don't show it in this summary here. But that will be in the more detailed version that comes out in a couple of weeks. Okay. And again, as I said, this is a little bit of a work in progress here. So just to show you what the interface looks like, let's see if we can. I think our network connection's a little slow here. Maybe we'll go back to the slides, and we'll show you where that is. So let's go to this block right here. So to connect this up to a proposed data sharing service that essentially has to use routines. This is the Python version. There's also a Java version that goes with this as well. So you get your choice there of languages to work with. But the actual calls are fairly straightforward. It's a matter of implementing a call to be able to set up the DSS for the test. That's essentially pre-reading all the subscriptions that go with the generators and the receivers, such that they can be handled by the DSS. There's connecting to the data sharing service. There's the key ones are submitting metadata, submit data content to the data sharing service, register as a data content receiver, and receive and process DSS metadata. And then there's another one for actually reading the data content block itself. So what we want industry to do here is to take our test driver and be able to edit the code that goes with this to be able to put the Offeror implementation inside that does the same thing that's going to be in the sample DSS test driver, DSS system that we're going to give you, and then be able to put that together and submit results back to the government. And then hopefully the government will get some great solutions here and be able to do a reasonable evaluation. So that's in a nutshell. I mean, there's a good bit more to the story here, but what we want to do is just give you a feel for what it is the government's looking for in the data sharing service, the core ability to load and retrieve blocks and be able to handle a publish-subscribe mechanism that's associated with that, and to be able to make that scalable across multiple virtual machines. And to be able to provide something where a third party, so what we really want is going back to the folks that are developing the algorithms, we want to isolate them from the details of how this works. We want them to speak in terms of entering subscriptions. So essentially the algorithms here, we want to abstract things so that all they're doing is registering for subscriptions, receiving the data blocks that say need them, reading them, doing the job of producing the next data block and being able to send that back up to the system, abstract all of this, and provide a solution that will manage multiple cases, be able potentially to look at the subscriptions in advance and figure out how to organize this across multiple VMs in a way that's logical, possibly co-locating some of the algorithms with the data, and essentially providing the government with a robust solution for this. So when the RFP is released, I think you'll have a chance to look at that and think out the solutions a little bit more that might map to this.
So what I was just saying earlier, so slide 20 here is a depiction of one of the services. So yes, all the other services in the SLA, to answer your earlier question more, are part of the RFP.
So, Alan, if I understand correctly, actually doing this, getting this and being able to run the test and give you back the results, that's not going to happen until the RFP timeframe sometime in February, or?
Right. I think that was what was on the earlier slide.
Okay. So but we're not responding individually to the RFP. We have to respond as a team with all the other services?
You would, yes, we're not shopping each SLA independently.
Right.
They come as a package to the team. The winning offer would then be providing all those services.
You mentioned AWS earlier. Is that for doing this testing to show the performance, or that's actually what you want to run it on?
So when you're doing this, you're going to be anticipating that you're going to run on the government-provided AWS, right? So we're expecting the Offeror to run this on commercial AWS. And so one of the other aspects of this is that this scales quite large. And so the amount of resources that are potentially consumed could be pretty large. And so we would like, to see the resource utilization as part of this outcome, because this is going to be an expense, that's incurred as a result of the solution. So we would like to see, how well you can scale and use resources effectively, so that you don't have things spun up, because today, we're running thousands of servers to do this. And so we would like to see a more efficient way of breaking this down to scale, so that you can use the resources only when you need them at the time you need them.
And the documents, images, whatever, need to be up to 10 megabytes.
Those are represented.
So Gary, based on that, on your statement, is it going to be more advantageous for us to like limit the footprint to get some kind of an optimized number versus expand to as big as we can to show like highly optimized?
It's
Or
going to
you
be,
need
yeah,
those
it's going to
variables?
be, you're gonna have to kind of balance that because, you know, in order to get the numbers that you are looking for, we're looking for, right?
Right,
We don't want to go with infinity resources.
right,
But to save cost, you know, it all boils down to, as far as selection, is how much this thing is going to cost the government, right? So we want to see how efficiently you can do that and still try to achieve those numbers.
right. But there will become a point to where, you know, you can, if the performance is one of the big deciding factors, then, you know, you can achieve different levels of performance by using different classes of the region, right?
Right.
But again, that was, just to sort of jump in, that was where I was saying the government wants to be in a room discussing the trade-offs between the mission apps and services and what the framework can provide.
Okay,
So that would be an ongoing conversation.
okay.
Can I paraphrase this? We're really just talking about SLAs here. Service level agreements,
Correct.
performance, you know, you want within a certain performance, and you want to minimize costs, that's just what it's about. You just want a cheaper black box to do it.
Right.
So this test that will be run, this will run for hours. So it's going to, you know, potentially cost, you know, the proposer some money to invest in commercial AWS, right, to run this thing for some time. So they have to factor that in as well. So you're not going to want to, you know, buy, you know, a bunch of Amazon instances out there, you know, they're going to be running for hours that don't run efficiently for your solution. And we're also adding simulated back pressure in this test driver to simulate the algorithms processing data so that we can see what happens to the framework if data starts to back up, right? So we're going to put those simulators in there as well.
And if you had an alternative cloud which was faster than AWS, which could also be certified to run at the government level, would that be interesting?
Yeah, there could be a hybrid approach to this as well. It doesn't have to be solely AWS, but we have to understand what the solution looks like.
Okay. Any further questions?
I'm happy to talk with folks afterwards.
Okay. Thank you. Thanks for having me.